We have a bounded region that's bounded by these graphs, and we want to revolve the bounded region about the line x equal to 4, and then find the volume of the solid of revolution. So this is the graph y equal to the square root of x. This is the line y equal to 0, and this is the vertical line x equal to 4. And this vertical line is also the axis of revolution. And so we want to revolve this bounded region around about this line. Since the axis of revolution is vertical, we'll fill the bounded region with horizontal rectangles, and then we revolve each rectangle around the axis of revolution, and that will give us the disk, and then find the volumes of all the disk and then add them up, and that will give us the volume of the solid of revolution. And so if we revolve this rectangle right here about the line x equal to 4, then we'll get a disk like this. And since this disk right here, it has no hole in the middle, we'll just use the disk method. And since the rectangles are horizontal, or the disk is horizontal, we need to go ahead and rewrite this equation right here so that x is a function of y. We do that so that we can set up the integral to find the volume of the solid of revolution in terms of y. So we have y equal to the square root of x, and then square both sides, we get the y squared, and then the square root of x squared is just x, and so we get x equal to y squared. And now to get the volume of the solid of revolution, we need to figure out what the radius of the disk is. And the disk the radius starts right here, and it, from here to the axis of revolution. Now the graph is x equal to y squared, and the axis of revolution is the line x equal to 4. And so the radius will be 4 minus y squared. So this is the line x equal to 4. This is the graph x equal to y squared. So the radius will be 4 minus y squared. And for this solid of revolution, y ranges from 0 to 2, because this point right here is the point 4, 2. So y ranges from 0 to 2. And so our the integral for this volume will have limits of integration from 0 to 2. And then so this is pi times radius squared times dy. But all of y is 4 minus y squared. And simplify, we'll get 16 minus 8y squared plus y to the 4th. Antiderivative for 16 is 16 times y. Antiderivative for y squared is y to the 3rd divided by 3. And we have an 8 here, so it's 8/3. And then antiderivative for y to the 4th is y to the 5th divided by 5. Evaluating from 0 to 2. So we put a 2 here, we get 16 times 2, which is 32. And we put a 2 here, 2 to the 3rd is 8, and then 8/3 times 8 is 64/3. And then put the 2 here, we get 2 to the 5th, 2 to the 5th is 32, 32 divided by 5. And then if we plugged in 0, we get 0, 0, 0. And so 32 minus 64/3 plus 32/5 is 256 over 15, and then times pi. So the volume of the solid of revolution is 256 over 15 times pi.